To help celebrate our release of the vintage penny humbucker helper copper guitar pick, I'm giving away a 1/10 of an ounce 0.999 silver guitar pick to one of the next 100 people to order and leave a review on their copper humbucker helper. Exclusive on Reverb. Click below.
We now join the following program already in progress.
Hello boys and girls, welcome to part 2 of this Ampeg restoration and repair. In the last video we left off, we were about to fire this thing up for the first time after having changed a bunch of parts, including the transformer, including all of the capacitors in the amplifier. We also cleaned the whole thing and all this, so we're about to fire this thing up for the first time and see what it does, so stick around. Okay, here's our customary halfway stopping point. Got 66 volts, 14 watts of power overall. Starting to get noise at the output. 0.2 amps. We've got pilot light on. We've got volume. We've got tone. And I don't know what's up with the foot switch. Or the trim, rather. Maybe the trim just needs more voltage to work. Got a little bit of intermittent noise, so we'll have to track that down, figure out what that is. Alright, there's our 120 volts. 0.73 amps. And yeah, we've got more noise than I would expect this thing to have, even with the volume kind of up. I wonder if this could be a case of the power transformer not being tightened down enough. That's possible. That does happen sometimes. Something's going okay. Well, there's our trim. Okay, I think what was going on there is that the trim was grounding out somehow, like, because there's no, this is not a two-layered board. On Fenders you have a bottom layer of material that keeps you from, you know, grounding anything out. And I think what was happening is when I installed this capacitor right here, I think it may have gotten hot and just gotten through the first layer of insulator on this wire. So that's a weird problem, but I think that's what happened there. Yeah, it's very noisy. That could be a preamp tube. Could be a power tube. There's an outside chance. Way too loud, way too noisy. Okay, that's weird. The microphone jack. Ah, the microphone jack. Something wrong with the microphone jack, I think. See there? And there's some clicking. I think it's inside the tube. The tube is physically clicking. You can hear it. It just sounds really glassy. Hang on, let me put the microphone up to it. I don't know if I've ever heard anything like this. Listen. Is it this one? Or is it this one? It's that one. There it goes again. Hear that? Isn't that strange? I don't know if I've ever heard a tube tick like that with the tremolo that I remember. Alright, well we've definitely got some noise issues. I need to figure out what's going on with it. Usually when you got noise issues, it's one of a few things. It's either tubes or it's grounding. It's usually one of those two. But let's look into it a little further and we'll see what's up. Alright, now as grimy as this thing was, I'm thinking maybe this is so dirty, the input jacks, that it's just, you know, they're not getting proper ground. So let's try that first, because a lot of times that does happen. Damn it. Yeah, that's really rusty and nasty. So I would not be surprised if that's the problem. If this is the problem, this will be the second Ampeg in a row with a problem on the input jacks not being properly grounded. Also, I'm not sure what's going on with that mic jack, but it was sounding horrible earlier. I don't know, man. I think I need to probably reflow all the solder on this and everything too. And these are just, they're really dirty. These jacks are dirty. I've already cleaned them too, and they're still dirty. Yeah, these suckers are dirty. Look at that. Just see how how oxidized everything is. I mean, it would not surprise me a bit if that was kind of the issue, but I don't know. I mean, it does seem to be present though, even when the volume's not up. So, you know, I'm going to get a couple of power tubes. I'm going to cycle those in. I'm going to also clean these and just make sure we're getting a good connection from here. I think that's about as clean as these jacks are going to get. So, let's see. The jacks are grounded though to here. But that's creating a loop. And once again, here's another example of there's two paths to ground here through these jacks. I'm curious now what it's going to sound like. Let's turn it on. I'll just leave the jacks dangling there for a second, and let's see what kind of noise it makes now. Now I can hear it already. It's physical. I think it's in the power transformer. Well, now it's oscillating like it has no ground at all. Okay. Alright, I think it might be a problem with this power transformer that I installed. I think it may be that it's not physically tightened in there enough or something, because it's humming even with even before everything warms up. You can hear the physical hum of it. Okay, so I flipped this chassis over, and I noticed that there was a bit of a gap in between this bell and the first lamination here. So I'm thinking that this thing is just physically making noise. And when I turn this, it's definitely turning. So, you know, there's some slack in there. So yeah, see there? That shouldn't turn like that if it's real tight. It's obviously not tight enough. So let's do that. I sure as heck don't want to take this whole thing back out. That's the last thing I want to do. With this edge, you can really see it. Yeah, see how it's, look at this, there's a gap right there, even. Watch that gap close. Hopefully, as I turn this. Yeah, that's loose as heck. Yeah. Well, that turned quite a bit. Should have tightened these before I installed this transformer. That would have been the thing to do. You laughing at me?
What the fuck is so funny about me? Tell me. Tell me what's funny.
Damn. Okay, let's try that again. Alright, jacks are installed once again. Let's turn it on. It's buzzing less. No, still not it though. Still didn't get it. I think it's somewhere in the power supply, maybe even somewhere. Something having to do with the way that the grounding scheme is happening over here. Okay, so this is another one of those damn situations where I've kind of been at my wit's end for about the last couple of hours poking around in this thing, changing tubes, all kinds of stuff to no avail. You know, lifting grounds, moving things around, and just can't seem to find out what the hell the problem is here. So I've got this dialed up on the Variac to 120 volts. So I've got it out, it's on the desk, and I was going to check and see if it's physically vibrating, and it's not. The fact that it's not physically vibrating out on the desk means that it's only doing it under load, and I need to find out which winding it is that's doing it. Now I disconnected the 6-volt winding earlier, and it remained, it kept buzzing. So the physical vibration is happening under load. It's not the 6-volt winding. I'm going to try putting the 5-volt under load, and then I'll try the high tension, and we'll try to you know, isolate it down to which load is causing it. Now I'm guessing it's going to be the high tension. I'm going to go through one at a time, put each of those under a load, and see when the vibration begins. Okay, well here we go again. Behold this lunacy. Attaching the 6-volt center tap to the chassis actually raises the noise. It actually increased the noise. So let's try pin 8. Increases the noise. So what's going on with the 6-volt winding? Alright, let's go to 110 there. So what's the deal with that? That is strange. Well, the foot switch is working now. It wasn't working before. There is a definite grounding issue here. Ampegs, man. I've just been screwing around with this seemingly forever, and finally have gotten something that is an acceptable signal to noise ratio, and I think the key to this is down to the input jacks once again with the Ampegs. I'm gonna have to do something to rework the input jacks. So you can see I've got them raised again here out of the chassis. Now there's a black wire. You can kind of see it back there. You see that black wire? Okay, it's running down to the grounding bus, and you know, when they're in the chassis, there's also another ground that happens at the point of the chassis, and I think the loop is being set up there. That's my best guess right now as to what's going on. It was there for a little bit, acting like this ground wire. Whenever I would connect it was actually creating more noise. Let's talk for a minute about proper grounding in electrical circuits and why thinking about grounding schemes both inside individual pieces of equipment such as guitar amplifiers and among many pieces of equipment such as in a studio or office is important, especially if you're trying to troubleshoot or prevent noise caused by electromagnetic interference. First, let's talk about what exactly we mean by ground. The term ground is often conflated to mean either circuit ground, chassis ground, or earth ground. But these are not the same thing, so don't confuse them. Circuit ground is best thought of as a zero reference point for potential energy or voltage inside an electrical circuit. This circuit ground is usually attached to the chassis ground at one point or several points in a star configuration, and the chassis ground is connected to earth ground at the star's central point and connected to the actual earth through a pole driven deep in the ground outside your home or office. All free electrons, such as the ones found in electronic circuits, ultimately want to get to earth ground. Any buildup of free electrons will together form a potential energy known as a voltage. Anyone who has taken a physics class might remember the concept of potential energy. This concept is probably most clearly represented by the apple hanging on the tree above the head of the unsuspecting Isaac Newton. The apple has a potential energy that is a function of its mass and its distance above Isaac's head. If the distance of the apple above Newton's head is increased, the potential energy increases. This increase in height and thus potential energy is like an increase in voltage inside an electrical circuit. Conversely, if the apple is lowered closer to Newton's head, the potential energy between them is decreased. This can be thought of as a lower voltage in an electrical circuit. In this example, Newton's head could be thought of as the circuit ground, and the apple's potential energy could be thought of as some positive voltage above his head. Now let's imagine our apple tree and Newton are both high up on a mountaintop. The potential energy between the apple and Newton have remained the same, but now the potential energy of both relative to the valley floor have increased. While Newton's head might still be thought of as our circuit ground or zero point in this circuit, there is now a potential energy between Newton's head and the valley floor below, which could be thought of as earth ground. The only reason we really care much about earth ground is for safety. If you imagine instead of apples falling, there are bolts of lightning, you don't want to be the conduit connecting this lightning to earth. So instead, what we do with our circuits is surround them in a cage or box that is a conductor. Then we ideally make one solid connection from circuit ground to the box, also called chassis ground, and then we make one more solid connection between this box and actual earth ground. In this way, even if the voltage got accidentally discharged to the box while our bodies were in contact with it, the free electrons wanting to get to earth ground would find it far easier to go through this good, solid, low impedance connection to earth, rather than going out of their way through your relatively higher impedance body. Now, if we look inside of a typical guitar amp, we'll see that there may be more than one point where the circuit ground connects to the chassis ground. In the case of our Ampeg, these connections were made from the factory at the capacitor can, at the input jacks, and also at the output transformer, not shown here. There was no direct earth connection. The center taps for both the 6-volt and B+ windings were connected to the capacitor can. This kind of situation can be okay unless in the process of connecting our grounds to multiple points, we inadvertently set up what's called a ground loop. A ground loop can be thought of as multiple paths electrons can take to get to earth ground. In this case, the input jacks were connected to both the chassis and the ground rail on the board, creating a loop. When electromagnetic waves or even a permanent magnet are moved in proximity to this loop, a voltage is induced in the loop, creating noise at the same frequency as the frequency of the wave or motion of the permanent magnet. This same principle is used in guitar pickups to generate the notes of a guitar. Here, the mains transformer was the source of the hum, with its 60 cycle 120 volt AC signal being induced into the nearby ground loop and heard as a 60 cycle hum. The same situation can occur in a studio with ground loops. Studios can have many pieces of equipment all with their own ground connections. Ideally, all chassis grounds for all equipment should be connected to a single outside point or piece of gear, and that point connected to earth ground, thus preventing nasty sounding ground loops in the studio, which can be hard to track down. And I don't know why they designed these like this. This is just, as far as I'm concerned, it's not right. If you go to change the caps, you have to, do something different with them, move them to the board like I have done. It just screws the whole scheme. I don't know why they would have the flow going to the input jacks rather than the opposite way like everyone else on planet Earth. So, crazy, but I guess it's something Ampeg did. I was unaware of that until the last Ampeg that I serviced, and then it just kind of became apparent. It was like, oh yeah, I guess that is what they do. Okay, so as this sits, I think I need to mount this and wire it in as it sits. Try to figure out something to do with the input jacks. I even went as far as lifting the... there are 2 points right there where grounds occur on the chassis as well, in the tone stack, those 2 tone capacitors right there. Or actually, well, 1 tone capacitor, and the other one is where the volume grounds. Now I'm going to have to add some more wires back onto this transformer because I clipped them all in anticipation of changing the transformer. Because I thought surely it's the transformer. It's got to be the problem because it was, it was physically vibrating at first, and that was part of the problem, I do think. But no, now it's definitely not. But this does at least afford us an opportunity to tighten those bolts. Okay, I want to show you something about this Ampeg. Now these 3 jacks, they're kind of floating in midair here, so just they're not connected to anything down there, obviously. But I want to show you something that's going on with these. This middle jack is the only one that has a an extra grounded element there. You can see the grounded element down there. So one would assume, that's for grounding things out whenever not in use. Because obviously, this is going to be grounded against the chassis. But no, that's not what's going on at all. If we take a gator clip, okay, and if we ground it to where it normally would have been grounded, somewhere over, over here-ish on the chassis, and if we press it to that, the noise actually increases. If I just press the gator clip to it, it's live. Alright, let's try to make heads or tails of this crap. So, right now I'm plugged into J1, so it should be going through a 47K resistor, and then we've got a 5.6 meg grid link resistor here. Okay, so we're running 2 of these in parallel. We have a 470 and a 5.6. Same thing with R3, or J2 rather. If you plug in a J2, jack 2, you're gonna get the same thing. It goes through a 47, and you're gonna get this one and this one in parallel. Yeah, if it's not grounded and you touch the ground, you're going through a 470 and then through a 47K, and then to the... Okay, so that's why. That's fine, but the problem is we have that second ground wire. I'm going to try to see if cutting that second ground wire or moving it has any effect, because right now what's going on is we're getting a lot of noise by having the jacks grounded to the chassis like they are. I'm kind of thinking I might have to end up isolating these the same way I did that last Ampeg. Okay, the resistors that we see on these jacks, I see a yellow, purple, orange. Yellow, purple, orange, that's 4, 7, and 3 zeros. So that's 47K. There's a yellow, purple, and orange as well. There's another 47K. And another yellow, purple, orange. So there are the 3 47Ks accounted for. Then we have a yellow, purple, yellow right there. That's the 470K accounted for. And that's where we should expect to see that. And we've got this. Green, blue, green. 5.6 meg that's supposed to be. Okay, if I try to measure it. And believe me, I've scraped off all the gunk, so I'm getting good connection, or I should be. I've got nothing. That's just, it's open. This is actually closer to the actual configuration of this amplifier rather than the one that I just showed a minute ago, because the ground connection is actually on J2 in this example I have rather than J3. But at any rate, if you plug into J1, you could see that you still have a ground reference if your 5.6 meg resistor is open. You still have a ground reference through the 47K and 470K resistors over here. If you go into J3, the same situation, you still have a ground reference for this first stage. You still have a grid leak resistance with that 5.6 meg open. However, if you plug into the middle jack here, you can see what's going to happen. You can see that if the 5.6 meg is open, you have absolutely no ground reference. You have no grid leak resistance, so there's no way an AC signal can set itself up because there's no reference to ground through a grid leak resistor. So, you know, I'm left with another example of an Ampeg that's just got some weird design features. And I'm thinking that, you know, making this something more Fender-esque or Marshall-esque is just going to simplify things, but I mean, I don't want to necessarily do that. I would like to, you know, leave it as original as possible, but the thing is, it's so damn noisy. Okay, I finally fixed the problem with all the noise. I isolated the input jacks just like I did on the last Ampeg that I did, and that took care of it. So all I have to do, really left to do now, is to put the center tap wire that in, and also I'm going to go ahead. I used more of a Fender input, and the third input is just frankly useless. You don't need a third input on one of these, and I think it would be better and more useful to do like a negative feedback control right there in that spot. So that's what I'm going to do. Let's insert a negative feedback. Okay, guys and girls, sorry to do this to you again, but that's going to about do it for this part 2 of this restoration on the 1962 Ampeg Rocket. Hope you've enjoyed this part of the series. In the next part of the series, we're going to finish out the modification on this thing that I'm going to put in, which is a negative feedback control. After that, we are going to turn our attention to the cabinet. We need to do some restoration work on the cabinet. There's some parts of it that are coming loose and so forth. And then finally, we will get to a demo of this thing, hopefully. So if that sounds like something you'd be interested in, please do subscribe. Also hit the bell to receive all notifications. I've had a real problem with people getting their notifications lately. So yeah, please be sure to do that. And for now, we'll see y'all later.